In section 2.4, we're going to be learning about linear functions. Now, linear just means line, and function we're going to talk some more about later on in the course, but you could see that line is built into linear. All right, so let's talk about this. Now, when we have a line, an important concept to know is called slope. What slope is that's just the slant of the line. So think about it as the slant. More specifically, we have a formula for it. We could think about it as rise over run. And remember, rise goes up and down, run, we go left and right. So as we rise, that's really just a change in the y value. Run is a change in the x value. That triangle means delta. It's not important that you know that. It's just an abbreviated way to say change. And when we're talking about change, like if my height changes from 6 feet to 6 feet 2 inches, my height changed by 2 inches, right? So you subtract them. So we're going to subtract the two y values, and we're going to subtract the two x values. Another way that I like to think about it, especially when I'm tutoring students, is the top number for slope tells you whether you're going to go up or down. The bottom number for slope tells you whether you're going to go right or left. If the top number is positive, you go up. Top number is negative, you go down. Bottom number is positive, you go right. Negative, you go left. So let's take a look at some sample lines. If you have a line that's rising from left to right, your slope is positive. We use m to represent slope. From left to right, if your line is flat, there is no slant, right? I mean, it's totally flat. If you went skiing on that slope, you wouldn't have a good time. The slope is 0. Generally, if we have a line that's horizontal, an equation for that line would be like y is equal to 2 or whatever the y-intercept is. If the line's going down from left to right, that has a negative slope. So the slope would be a negative number. And then if you have a line that doesn't really do anything left to right, if it's just vertical, we say that the slope is undefined. Because what happens with this line is whatever number the top is, you would always have like 0 on the bottom. You can't divide by 0. That's impossible. So we say that this is undefined. Now, if you ever wondered why that is, I'll give you like a little history of this. This isn't important for the lesson, but being a college class, I think it's important that you know this. What does 8 divided by 2 mean? It's 4, right? Because what I'm asking you is 2 times what number is 4? Or I'm sorry, 2 times what number is 8, right? The dividend. And the answer is 4. And that's the answer. 8 divided by 2 is 4 because 2 times 4 is 8. So if I asked you what's 10 divided by 5, really what I'm asking you is 5 times what number is 10? Everyone knows the answer is 2, right? So what if we put a 0 on top? What this is saying is 2 times what number is 0? Well, of course it's 0, right? So if 0 is on top, like you would have for a horizontal line, the slope is 0. But if we switch and put 0 on the bottom, what this is asking you is 0 times what number is 2? And I have no idea. It doesn't work, right? There's no defined number that makes that happen. So we say anytime 0 is on the bottom, that's undefined. If you have a vertical slope, the slope is undefined. That's the only acceptable answer. You can't say there's no slope. That's not okay. The slope is either 0 if it's horizontal or it's undefined if it's vertical. And those kind of lines say x is equal to like 2, whatever the x-intercept would be. We'll talk more about this stuff later on. So let's define what a linear function is. So a linear function is when one or both powers of the variables are equal to 1. So if you had x to the first is equal to a number, that's a linear function. Well, that's a line. It wouldn't quite be a function. That was a bad example. If you have like y is equal to 2, that's a linear function. If you had y is equal to x plus 2, that's a linear function. All right? If you have x is equal to a number, that's not a function. It's a line. When we talk about functions, you'll see why that's not actually a function. All right, so generally our linear functions take the form f of x is equal to mx plus b. F of x just means function of x, just meaning that we're going to be plugging in numbers for x. Most of the time, you guys probably know y is equal to mx plus b. This is slope-intercept form. Slope-intercept form, where m is our slope and b represents our y-intercept. So let's get into some examples. First, let's see here. Let's find the slope of a line. So we'll get some practice working on the slope. First example is, what if I gave you a point -4, 8 and another point 2, -3? Well, our formula for slope is we subtract the y values over we subtract the x values. Now it doesn't matter which one you want to label y2 or y1 as long as you're consistent. So I'm going to subtract this y value minus that one. -3 minus 8 over, I'm going to go in the same direction. I always use arrows for this to make sure I'm going in the same direction. 2 minus -4. Make sure you have the negative there, right? It's minus a negative. So this would just be -11 over 6. And that's the answer. That's the slope. The line would be going down from left to right. And just as a side note, remember -11 over 6 is the same thing as 11 over -6 or -11 over 6. Those are all equivalent fractions. It doesn't matter where the negative is. It could be in the numerator, denominator, or in the middle. How about something like this? What if we had 4x plus 3y is equal to 12? And we want to find the slope of that line. Well, one way we could do that is we can convert it to slope-intercept form. So let's make this look like y is equal to mx plus b. We talked about in a previous section how to solve a literal equation, and that's what we're doing here. So we want to get the y by itself. So let's bring the 4x over, subtract that on both sides. We get 3y is equal to -4x plus 12, and I'll divide everything by 3. So we do get y by itself is equal to -4/3 x plus 4. The slope of this line is -4/3. All right. One thing I just want to point out too is I could teach you a little shortcut. When you have something written like this, ax plus by is equal to c, that's called standard or general, depending on the book. Most people just call it standard form. And if you ever have anything written in standard form, there is a shortcut with finding the slope. We could do exactly what we did before. Let's get the x on the other side. You don't have to know how to do this, but some of you might be interested in this. And you could divide everything by the number in front of y, just like we did. So one shortcut, if you have an equation in general or standard form, is going forward, the slope is always the opposite of A over B. Well, look, if we take a look at this, here's A and here's B. The opposite of A, -4 over 3, is exactly what we got over here. So we don't have to manipulate it every single time. If you just remember the shortcut, this would always give us the slope, and this would always give us the y-intercept. All right, a couple more examples I wanted to go over. What if I asked you to graph by finding the x and y-intercepts? And then we're going to state the domain and range. Now, domain just means possible x values. Range just means our possible y values. So let's take a look. I have 4 examples here. First problem looks like this. F of x is equal to -2x plus 6. Now, I asked for the x and y-intercepts, but there's no y. So f of x is just a fancy form of y. F of x just tells you that it's a function, but really f of x and y are the same thing. F of x just tells you a little bit more information. The way that we get our x-intercept is we make y equal to 0. The way you find your y-intercept is you make x equal to 0. Now think about this. If you have a graph and you want to know when it crosses this line, it's a horizontal line, right? We said that all horizontal lines have the equation, what? Y is equal to 0. So if we want to know where it crosses the x-axis, we use y equals 0. And it's the same thing for vertical lines. If we want to know where the graph crosses this line right here, that's the y-axis. We want to know what the y-intercept is. Well, what's the equation of that line? That's just x equals 0, right? So that's why we have it here. So let's go ahead and do this. For the first one, if y is equal to 0, we get 0 is equal to -2x plus 6. Bring the 6 over, and we get x is equal to 3. 1, 2, 3, right there. Let's label it. If we want to find the y-intercept, we're going to put 0 in for x. Y is equal to -2 times 0 plus 6. Y would equal 6. That's pretty easy. 1, 2, 3, 4, 5, 6. Connect the dots. And there would be our line. Now, as far as what the domain is, what are possible x values that we could plug in to our original equation? We could plug in any x values we want. I mean, look at the graph. It looks like every x value on the graph would have a corresponding y value. Say if x was 5, well, you'd have a point on the graph right here. What if x was 100? Well, you have a point on the graph right here, right? So the domain would be all real numbers. And we could write that from -infinity to +infinity. And as far as our range, what are our y values? Well, look at the graph. It looks like it covers everything. All positive, all negative numbers, it's going to keep going up. It's going to keep going down, so it's the same thing. We have all real numbers for the range. Infinity is a little tricky to draw. It's just kind of an 8 laying sideways. All right, let's do another example. What about if I asked you to graph f of x is equal to -3? We know at this point f of x is y. So whenever we have y equals anything, put our dot here. wouldn't make sense to draw a line here, because what would be the difference between y equals -3 and y equals like 1, right? So anytime you have y equals anything, it's a horizontal line. The slope is 0. The x-intercept, well, it never crosses the x-axis, so we're going to say none. You don't want to say 0 because that would mean it crosses when x is 0. The y-intercept, well, clearly it crosses when y is equal to -3. Now you could either write it like this if you want, or, you know, some people prefer to write it like this. Totally fine, whatever way you like. Domain for this, possible x values. Well, this graph stretches all x values, all positive x values. If x is 100, what's y equal to? -3, right? It doesn't matter what x is. You could plug in any x value you want. So the domain would be all real numbers. But as far as the range, the only y value we're using is just -3, right? So we could even write that like this. That would be the only way to do this. Okay. A couple more. What about if we said x was equal to -3? Remember, anytime we have x is equal to anything, we could draw it, but it's a vertical line. So when we're talking about the x-intercept, well, clearly it crosses at -3, right? That's what we said. It should be there. My hand was covering up the negative. So the x-intercept would be -3. The y-intercept, well, it never touches the y-axis. It's parallel to that. So we're going to say none for this. The domain, what are possible x values we could use? Well, the only x value we could use is -3, right? We have no idea when x is 2. I mean, that's the problem just says x is equal to -3. But as far as our range, if you look at the graph, the range is covering all positive x values, or all positive y values, all negative y values. So our range would be all real numbers. One more example like this. What if we had 4x minus 5y is equal to 0? Well, this is a little tricky, because if we try to get the x-intercept by making y is equal to 0, we get 4x minus 5 times 0 is equal to 0. So 4x would equal 0, divide by 4, number of zeros on top, the answer is just 0. So the x-intercept is 0. The y-intercept by making x equal to 0, we are going to get a similar situation. Okay, so if we go to graph this, whoa, that's not a very good axis. The x and y-intercepts are both 0, right? So how do we graph the line? Well, getting the x and y-intercepts didn't really help us, but we do have another way to do it, and that's converting this to slope-intercept form. Because if we know what the slope is, then we could graph it. Now remember the shortcut. If we want to get the slope, we could just take the opposite of a over b. So the slope is 4/5. Top number is positive 4, so from our point we're going to go up 4, and then to the right 5. I use the shortcut that I showed you before with the opposite of a over b. Now if you don't want to remember the shortcut, what we could do is we could always just manipulate this and get the y by itself. So let's subtract 4x on both sides, and then divide by -5. We get y is equal to 4/5 x plus nothing. The nothing is your y-intercept, which we already know, and this is our slope. So there's a few different ways to get that answer. Last example for this lesson is let's graph the line through -1, 5 having a slope equal to -5/3. Okay, so our point was -1, 5, right there. Now from there, the slope is -5/3. So the top number is negative, we're going to go down. Bottom number is positive, so we go to the right. So from that point, -1, 5, I'm going to go down 5. 1, 2, 3, 4, 5, and to the right 3. 1, 2, 3. Yeah, and that's how we do a problem like that. Stay tuned for the next lesson.